Hello. Mm, Muskan, are you getting my voice? Okay, okay. Okay, so good afternoon, all of you. Just wait few minutes for rest of the students to join in this session. Then we will continue the session. Okay, so let's start the session actually. And you are getting the whiteboard. You are watching now the whiteboard. Yes or no? Hello.
Yes, sir.
Okay. 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 So very good afternoon for all of you. And actually, in the last class, we have started discussion about the what is the race around condition. So in the race around condition, actually, in the last we saw the JK flip flop, and we can see we can see one condition. So whenever the j equals to 1 and k equals to 1, so in that time actually we are getting some racing. Okay, so last state actually. So from this actually here we will try to overcome this problem here. So first we will discuss here the race around condition. So this is race around condition or racing condition. So for this, I am here drawing the flip flop. Just give me a few seconds to draw. Okay, so this is the JK flip flop. Okay, so this is JK and this is K. Okay, and here we are considering this is Q and this is Q bar. So earlier we saw the D flip flop and the SR flip flop, and we got that in the last steps. Actually, we are not getting the proper output whenever the SR is 1 1, and in the case of J, the last test, we are actually not getting the proper output. So to overcome this proper output, we here learned the JK flip flop. So actually, in the case of JK flip flop, we already see that in the last test, whenever we are giving the J equals to 1 and the K equals to 1, so in that case, that we are actually getting the racing condition. So now our aim is to overcome this racing condition here. Now, so first, so that the last is that is the racing condition, and in the race around condition, it is very important in your for your examination. And there is another concept, that is the master slave is our flip flop or JK flip flop. Sorry, JK flip flop. So uh, actually, master slave JK flip flop is a way to overcome the racing condition of JK flip flop. Okay, there is another way also. Now for this, actually, we are what is the racing condition or the race around condition. So for here, actually, we are considering that here J equals to 1 and K equals to 1. So here J equals to 1 and K equals to 1, the clock is also 1. And here we assume here that Q equals to 1 and Q bar equals to 0. So earlier, a minute. For the case of JK flip flop, earlier we assumed that Q equals to 0 and Q bar equals to 1. So to know the racing condition or the race around condition, here we are assuming that Q equals to 1 and Q bar equals to 0. Now for this here, actually, I am writing the truth table of JK flip flop actually. So here this is clock, this is J, this is K, and this is Q n plus 1. And okay, so here one thing, this is 0 x x 1 double 0 1 0 1 1 1 0 1 1 1. So here actually this is Qn, this is also Qn, this is 0, this is 1, and for this just 1 minute. Okay, so this is the truth table. That's here. This is clock j k and q n plus 1, and this is the last one is that q n plus 1 bar. Okay, mainly the you can say also this is q n and this is q n bar. Okay, now the thing is that here actually here actually we are considering that j equals to 1, j equals to 1, and clock equals to 1, and we assuming that q equals to 1 and q bar equals to 0. Okay, now I am giving the input. So here actually this q, this output here, this q is connected with this NAND gate as a input. So here this the input is 1 1 and 1, and here it is this q bar is connected with this NAND gate. So here it is 0 1 1 from j and clock for 1. So 0 1 1. So as per the NAND gate, we are getting from here that 0 1 1 means 0. So after that at this point the output is 1, and here this is 1 1 1. So from 1 1 1 we are getting 1. So after this as per the truth table, here we are getting it this point, this is 0. So the final output here it is here in this point the output input is 1, and this point the input is 0. So the final output from where we are getting this is 0 and this is 1. So for this now you can see here the value of q and q bar, the value of q or q bar is changing. At this moment the value of q is 0 and the q bar is 1. So again at this moment here this q is connected with this NAND gate as a input. So at this moment the value is 0. So this is 1 1 0, and this is the q bar, the value of q bar is 1. So this is 1 1 1. So at this point from this as the input, here the NAND gate is 1 1 0 and here it is 1 1 1. So from this as per the truth table we are getting that 1 1 1. So after that we are getting as output here that is 0, and here this is 1. So if I am getting here at that point the input here is 0 and 1, so the main output here we are getting again this is 1 and this is 0. Okay, so here you can see the input also changes correspondingly the output also. So here again the value of q is at this moment it is 1 and the q bar is 0. So if I consider here again, so here at this point the value of q is 1 and the q bar is 0. Q bar is 0. So this is 0 now. So from this again we are getting this is from 1 and this is here at that point now it is 0. So the final output here for this condition you can see here at this moment it is 0 and here it is 1. Okay, so actually from here you can see for the case of q the value is changing from 1 to 0 0 to 1 like that, and the q bar is changing from here you can see this is 0 to 1 1 to 0 0 to 1 like that. Okay, so this condition actually called the race around condition. This condition is called this condition is called race around condition. Now you earlier already got a concept about the toggle, but there is little bit difference between the toggle and the race around condition. Sir, what is the difference? The difference is that the toggle state you can control, but the race around condition is not controlled. Okay, so we are trying to make it toggle, because I have said the toggle is controlling the toggle state we can control, and for the race around it is not controlled. Okay, so here actually we are trying to make this race around condition as a toggle condition. So if I draw here the, just a minute. If I draw the just give me a few seconds to draw the diagram. This is like clock. This is J and this is K. Okay, and here the clock is 0 and it is clock 1. So for this here actually it's like this. Like way. Okay, so here actually mm, okay, so here you can see at this point the clock is 0, and where this point is clock is 1. Okay, so again this is 0 and this point is 1. Okay, like that, and here j equals to 1 and k equals to 1. Now if we see this pulse with my actually with my clock pulse. So here actually we can see that for this case we race around condition, the clock is 1, j equals to 1 and k equals to 1. Okay, so for this here q n plus 1. So here actually like q n plus 1. So this is now we need clock equals to 1. So here it is like that. Okay, this is 0 again. Okay, next again this is so this is the actual the clock pulse. You can see here the racing condition of JK flip flop. Now one the thing is that this is called the time period. If we consider here from this to this is T, this is T. Now for here always our it should satisfy the condition that is T by 2 greater than delay. So here what is delay? Delay means that once you have changed the input and made the output high, so this gates require the own time to generate the output. Okay, so this is called the delay. Now here actually to overcome the racing condition or the race around condition, there is some uh, yeah, there is some condition. So what are the condition? So actually conditions to overcome racing. First is t by 2 less than propagation delay of flip-flop. Second is age triggering. So you already know the age triggering and the label triggering concept. So you should follow the age triggering to overcome the racing. And the third one is the master slave. Master slave master slave condition. Okay. So you have any doubt for the racing condition or the racer and condition? How to overcome all these things? Okay. So you have no query, no doubt. So I am giving you 1 minute. All of the participants write your name in the chat box for the attendance. I am again requesting you, all the participants, write your name. At this moment, there is 34 students, 33 students. I am getting only the 29 response. Okay, so again, let's start. So we have discussed here the risk and condition, and I said that to overcome the racing condition, there is a one concept, the master slip condition, master slip JK name mainly. But today I will not discuss this topic. Okay, I will give you home tasks that you will study from the other sources. But if you face any difficulty in the next class, you definitely say that you are not getting, then we will discuss. Okay, now the thing is that today we will discuss, that is the thing, that is the SIP register. Okay, so first, just 1 minute. Now to discuss the first, the SIP register. SIP register. So we know that the flip-flop can store 1 bit of information. Now, if we try to store the multiple bit of information, then we require the flip-flop. Now, the group of flip-flops which is used to hold or store the binary data, that is known as the register. Now, if that register is capable of shifting bit either towards the right hand side or towards the left hand side, so then it is called the shift register. So when the shifting property is there in the register, then it is called the shift register. Now for the n bit shifting register, we need n flip flop. For n bit shifting we need n flip flop. And there is some category. So mainly there is 4 types of SIP register. In short, I am writing here, that is serial in, uh, CISO, serial in, serial out. Next is SIPO, serial in, parallel out. Next is parallel in, serial out, and the last one is parallel in, parallel out. So these are the 4 SIP register. First one is the serial in, serial out. Second one is the serial in, parallel out. Third one is the parallel in, serial out, and the fourth one is the parallel in, parallel out. Okay, so first we will discuss here, that is the serial in, serial out SIP register. So for this, suppose we have 3 flip flops. Okay, and this is clock. This is serial input, and this is serial output. Sorry. This is, and this is, and this is Q2. This is Q1 and this is Q0. So this SIP register, actually this is the CISO SIP register. So here the SIP register that is actually allows the serial input and produce the serial output, that is known as the serial input serial output SIP register. Now the block diagram is that 3-bit SIP register. Here actually this block diagram consists the 3-bit D flip flop. Okay, 3 D flip flop, and which is connected to each other. Now this means that actually the D flip flop that is connected as the input of the next D flip flop. Okay, one thing is that, and here the clock pulse is connected here. The clock pulse and here actually in this SIP register we actually send the data bits serially from the this left hand side SIP register to the right hand side SIP register. Okay, so here actually the input, here you can see this is the serial input and the rightmost this is the serial output. Okay, so if we example here, if we consider a truth table like that, it is not truth table, following table you can say. This is a number of positive edge pulse serial input. Next is Q2, Q1, and Q like 0. I am just erasing, okay, these things. This is serial input. So first I'm giving the clock here edge pulses. So here this is 0. So for here actually we are considering actually the 3-bit SIP register by sending the binary information, that is 0 1 1 0 1 1. Okay, one thing, and from the left hand to right hand side, and one thing that initial status, that is the Q2, Q1, and Q0. So for both these three actually Q2, Q1, Q0 equals to 0. So for Q1, Q2, sorry, Q0, Q1, Q2 have the value that is 0. Okay, now the thing is that here I am giving 0. So serial input, there is no serial input. So at this point the value of Q2, Q1, Q0 is 0 0 0. Next is I am giving the positive edge pulse 1. So if I am giving here positive edge pulse, so here at this point now the serial input that is 1 here. So this is 1. So here actually from this actually the value of Q2, so this one is shifting here, the value of Q2 is 1 at this moment, and the rest of the two, that is Q1 and Q0 is 0 0. Next is that number of positive pulse, it is 2. The previous case here Q2 equals to 1 and Q1 equals to 0 and Q0 equals to 0. Now I am giving again 1. So at that point again I am giving here 1. So the serial input here 1. So this 1 at this point, this Q2 is shifted to Q1. So and the serial input shifted to Q2. So here the value of Q2 again 1, and at that point the Q1 is 1 and the value of Q0 is 0. Next, the positive edge pulse number 3. So again I am giving that here 1 minute. So here actually serial input at that point, here you can see the last case it is 1, here it is also 1 and it is also 0. So this 0 is shifted here again. So at this point it is 0. So if it is 0, the value of Q2 is at this point 0. So Q1, so it is shifted. So Q1 is 1 and the value of Q0 is 1. Next the number 4. So for number 4, actually there is no value. So it is already, yeah, undefined. So here at this point, Q2, it is undefined. So the previous case was, it is here it is 0 at this point, and the last case, this Q1 previously it was 1, so here Q1 now 1. Okay, and the last here for the case of 5, so this is undefined, undefined, only the last case at this moment 1, so it is shifted to 0. Okay, so here actually the initial status of this D flip flop in the absence of the clock, the signal was Q2, Q1, and Q0 equals to 0, 0, 0. So at this point, at this actual point, the serial output is coming from this Q0. Here you can see the serial output. This is the serial output, and this is the serial input. Okay, so from this actual table, we can see that the 1 is received at the LSB 1 is received at the third positive clock pulse. Okay, and the MSB, that is 0, is received at the fifth positive edge clock pulse. Okay, so from this table we can conclude that the 3-bit CISO shift register requires the 5 clock pulses in order to produce the valid output. Okay, so similarly in the case of n-bit CISO register, CISO shift register required two n minus 1 clock pulse in order to shift n-bit information. To shift n-bit information. Okay, so this is the funda. So actually in the next class we will discuss the rest of the 3, that is